18A. Number 1. The figure below is a probability histogram for the sum of 25 draws from the box. 1, 2, 3, 4, and 5. The shaded area represents the chance that the sum will be between blank and blank. Between 70 and 80. Okay? So the shaded area, that middle section, is between 70 and 80. Okay? Oh, figure 2 is just a... Wow. Okay, that's weird. All right, number 2. The bottom panel of figure 1 on page 311 shows the probability histogram for the total number of spots when a pair of dice are rolled. The chance that the total number of spots will be between 7 and 10 inclusive equals the area under the histogram between so inclusive. It will be, you were just going to add up the areas between 7 and 10. Oh, I see. Oh, yeah, I see what they're asking. So you're going to add up everything from 7 to 10, but if you look at the areas, so we need to go to the probability histogram. We're going to add up all of the 7s and 10s. So this is the area that we're going to add up, but the areas are between 6.5 and 10.5. Okay, you guys would have figured that out. And B, the chance that the total number of spots will be 7 equals the area of the histogram between 6.5 and 7.5. Okay. This exercise, like exercise 2, refers to figure 1 on 317. If a pair of dice are rolled, the total number of spots is most likely to be which number shows up the most? 7. Okay. And then in 1,000 rolls of the pair of dice, which total came up most often? 7 did. Okay. And then in the top panel of figure 1, the rectangle over 4 is bigger than the rectangle over 5. Is this because 4 is more likely than 5? No. So what's the explanation? Chance error. Right? 100 rolls isn't very many, and the chance error just made the 4 bigger than the 5, which is not what is expected to happen, but it can happen. Okay. D, look at the top panel of the figure. The area of the rectangle above 8 represents 1, the chance of getting a total of 8 spots when a pair of dice are rolled. True or false? Right. So, is 1 possible? No. Okay, 2, the chance of getting a total of 8 spots when 100 dice are rolled. That's also false. In this case, it happened, but we wouldn't expect that. And 3, the percentage of times the total of 8 came up in table 2. That would be true. Number 4, figure 2 on 313 is about the product of the numbers on a pair of dice. So if you look at, so figure 1, we add up all the dice, we count the sum of the dice. Okay, now we multiply the dice. Figure 2 is a multiplication. Does it seem like there's some sort of pattern? Well, there are a whole bunch of gaps. Why are there a bunch of gaps? Look in figure 2 on page 313. How come 13 and 14 don't show up ever? You can't get a 13 or a 14 when you multiply. Right? We're multiplying the numbers 1 through 6 by the numbers 1 through 6. The only possible outcomes are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 15, 16, 18, 20, 24, 25, 30, and 36. Can we represent that using a normal curve? Not really. We could transform it and create a normal curve, but as written, it's definitely not normal. So, A, if the dice land 1, 3, what is the product? 3, and if they land 2, 3, 6. So B, 2 is as likely a value as the for the product as 3. Where would we find that? We're going to look at the probability histogram. Are 2 and 3 equally likely? It looks like 2 shows up about 6%, and 3 also shows up about 6%. So the two areas in the probability histogram for 2 and 3 are the same. In 1,000 rolls, what value appeared more often for the product, 2 or 3? In 1,000 rolls, 3 showed up a little bit more often. Is that expected? No. None of the histograms has a rectangle above 14, or for number 14. Why is that? You can't create a 14 using multiplication with numbers 1 through 6. In the bottom panel, the area of the rectangle above 6 is about 11.1. What does 11.1 mean? You have 11.1% chance of getting a 6 when you do a product. Okay. And 5, the figure below shows the probability histogram for the sum of 25 draws made at random with replacement from the box 1 and from box 2. Which histogram goes with which box? So histogram A belongs to box I. How come? Smaller sum. So if we found the average of the box would be 1. And if we make 25 draws, 1 times 25 is 25. That's the expected value. For box 2, what is the average of the box? 2. And if we do 25 draws, that gives me an expected value of 50. Now, can I use the standard normal curve for both of them? Yes, but they're different shapes. How do we convert each shape into the standard normal curve? What makes up the difference? And in this case, it's the SE. The SE will compensate for the width, and it will turn it into the standard normal curve. That's what the SE and the SD do. Okay, 6. The figure at the top of the next page is the probability histogram for the sum of 25 draws made at random with replacement from a box. True or false? The shaded area represents the percentage of times you draw a number between 5 and 10 inclusive. So we have the box from 5 to 10 shaded in. Does that area represent the percentage of times you draw a number between 5 and 10? No. How come? Well, what does that histogram represent? What is the x-axis? Value of the sum. So does it tell you how many times you draw a number between 5 and 10? No, it tells you when the sum of the draws is between 5 and 10. So that one's false.